Hello students, welcome to Wondercom. We are discussing electrochemistry. In the last video, I discussed about electrochemical cells, standard electrode potential as well as standard cell potential or EMF. In this video, I will discuss some important terms of thermodynamics. How thermodynamics is related to this electrochemical cell. It is important to know why do we need to study these thermodynamic terms in electrochemistry or electrochemical cells, because there is one common term that we should know in both, that is in thermodynamics as well as in electrochemistry, and that term is spontaneous. And if you remember in the first video of this electrochemistry, where I have given the definition of electrochemical cells, that I told you the electrical energy that is obtained from electrochemical cells from the spontaneous redox reactions. And this spontaneous or the spontaneity of a reaction can be defined by the term like entropy. Not only entropy, this spontaneity can also be defined by free energy. So both these terms are for thermodynamics. So to relate the spontaneous process in electrochemical cell or electrochemistry, we need these terms of thermodynamics. So let us first discuss about entropy and how it is related to the spontaneity of the chemical reaction. Before going for detail of that, I would like to tell you about the spontaneous process. We know a spontaneous process is either a physical or a chemical change that occurs by itself. That means it doesn't need any external force to carry out the process. For an example, in case of rusting of iron, in presence of moisture or flowing of heat from a hot body to a cold body, or in case of falling of a rock from a high hilltop which is rolling down automatically without any external forces. That means what we have understood from these processes is that these processes do not need any outside force to work out, but they continue until attain the equilibrium. So what is a spontaneous chemical reaction? That means the reaction that favors the formation of products at the condition under which the reaction is carried out. So reactants, whatever the condition given, at the given condition, it should give the products. So we can tell, so this is a spontaneous reaction. Whereas in case of non-spontaneous, the reaction doesn't favor in the formation of products. That means at the given condition, we are not going to get the products from the reactants. And as per the second law of thermodynamics, all this spontaneity in the process can be defined by a term known as entropy. So, which is, this entropy is nothing but the measure of the disorderness or the randomness of a system. or even the surrounding. The entropy is denoted by S. So when spontaneous processes occur, then there will be increase in disorderedness or the randomness of the components or the molecules present in the system. The entropy is said to be increased. So the thermodynamic system with the more randomness or the disorderedness implies that the system has high entropy, or the change in entropy is said to be positive. So obviously when the change in entropy or delta S is negative, then the system is less disordered or said to be more ordered. So we have understood that this entropy is the term which is a fundamental measure of spontaneity, where the spontaneity is the increase in entropy of both system as well as the surroundings. So for that reason, it is not that easy to measure the spontaneity at the point of equilibrium. And here the electrochemical cells are the systems and they attain equilibrium. Therefore, the term free energy is derived to measure the practical uses of or which is applicable to the system alone. It won't consider the surrounding. Hope you have understood the term spontaneity and its relationship between entropy. So in my next video, I will continue with the free energy change and its application in deriving one of the most important equation of electrochemistry, that is Nernst equation. So keep watching, keep learning. Thank you.